What is the relation between cylindrical coordinate and spherical polar coordinate? Consider a point P. The coordinate of point P in spherical polar coordinate is r theta phi. Here r is called the radial distance. This is your radial vector, and its magnitude is called the radial distance. Theta, this theta is called the polar angle, that means the angle from the polar direction, and phi is called the azimuthal angle or angle in the xy plane. So the coordinate of the point P in the spherical polar coordinate system is r theta phi. The same point P having coordinate rho phi z, this is in cylindrical coordinate. Here the rho, this is the radial distance. This is the radial distance in the xy plane, and phi is the azimuthal angle or angle in the xy plane, same as the angle in spherical polar coordinate, and z is the distance along the z direction. This is your z axis, this is your y axis, and this is your x axis. So z is the distance in the cylindrical or in the cylinder along the z direction. So now we will establish a relation between cylindrical and spherical polar coordinate. You see the radial distance r, this radial distance r makes an angle, suppose theta, then this component will be equal to r cos theta, and this component will be r sin theta. So the radial distance have two components, one is your along z axis, another along y axis. So this r cos theta component, this will be parallel to this z, which is in cylindrical coordinate. So one relation you can find out between cylindrical and spherical polar coordinate, that is z is equal to r cos theta. Then second thing, if this angle is equal to theta, then this angle also will be equal to theta, and if you draw a perpendicular here, then this will be a right angle triangle. This angle is right angle. So this component of r, if this will be a right angle, this component of r will be equal to r sin theta component, and this component of r will be cos this component will be r cos theta component. You see, if this angle is 90 degree and this is theta, then the component of r along this direction will be r sin theta, and component of r along this direction will be equal to r cos theta, this one. So r sin theta will be equal to the rho, that is the radial distance in cylindrical coordinate. So another relation between cylindrical and spherical polar coordinate will be rho is equal to r sin theta. Okay, one relation is z is equal to r cos theta, the second one is rho is equal to r sin theta. Then what will be the third relation? You see, r square, okay, r square will be equal to rho square plus z square square root. Since this is your right angle, so this is your z square, this component z square plus this component rho square will be equal to r. So you have three relations between cylindrical coordinate and spherical polar coordinate. One is your rho is equal to r sin theta, the second one is z is equal to r cos theta, and the third one is r is equal to rho square plus z square square root.